Hello students, welcome to my video lecture. First Brahmanad. Om Shanti Shanti Shanti. In last class we discussed the fundamental of probability, that is sample space, event, elementary event, exhaustive event, mutually exclusive event, equally likely events. Okay, today we are going to discuss algebra of event, algebra of probability. Next one, some elementary properties of probability. Okay, the first, algebra of events. As we discussed earlier, the sample space is the universal. Sample space can be taken as universal set, and all the events are the subset of sample space. All the events are the subset of sample space. Okay, again, the universal set means S is the possible outcomes of the possible outcomes. It is known as sample space. So S can be taken as universal set. Probability is purely related to the set. Okay. Algebra of events. Algebra of events. As we discussed earlier, okay, as we discussed earlier means set. Earlier, a sample space is a universal set. A sample space is a universal as a universal set of all possible. Universal set of all possible outcomes. All possible outcomes of an experiment. Okay. And the events are subset of, and the events are subset of the sample space S. Some subset of the sample space S. Of the set S. Okay. Of the sample space S or of the set S. Okay, with this assumption, with this assumption we have the following notation. We have the following notation regarding and results regarding sets. Notations and results in the probability of events. Okay, let A, B, C are any three events. Let A, B and C are any three events, and let S be the sample space. Okay, then first point A union B, or we can say A or B, means A union B or A or B means at least one of A and B occur. At least one of A and B occur. At least, minimum gote. At least one of A and B occur, or occurrence of at least one of the events A and B, or occurrence of at least one of the events A and B. This is A union B, or A or B means at least. Okay, next 2, A intersection B. A intersection B means kona, or double implies padla madhidi, or we write A and B. A and B means what? Na common A and B occurs, means both A and B occur. Simultaneous occurrence of both A and B. Okay, both the events A and B. Both the events A and B, or A intersection B means occurrence of A as well as B. Okay, both A and B occur. Both A and B occur. This is A intersection B. Next one A dash 3. A dash or A upper complement. A complement means A complement denote the events non-occurrence of the event A. Denote the event non-occurrence of A. Non-occurrence of A, not A. Non-occurrence of A. No, that is not A. Okay, not A. This is A dash or A complement. Next 4 A minus B. A minus B means the event occurrence of A but non-occurrence of B. Occurrence of A but non-occurrence of B. A minus B occurs. A occurs but B not occurs. A occurs but B not occurs. A occurs but B not occurs. Okay. So A minus B को हम लिख परिबा. We can write also. We can write A minus B is equal to A intersection B dash and B minus A is equal to B intersection A dash. A minus B. So in the set theory, this is A minus B. This is A and this one B. So this is sample space S. So this is called A minus B. A minus B. This is A minus B. So only A is called A minus B. That implies A minus A intersection B. This also B minus A intersection B. Okay, this is B minus A. This is B minus A. Okay, this one A minus B, this one B minus A. Okay, next fifth one. Fifth one, A union B is equal to B union A means commutatively satisfy करुछि हैला. Next sixth one, A intersection B is equal to B intersection A means commutative law satisfy both union as well as intersection. Next seventh one, A union B union C is equal to A union B union C. Associative law satisfied. Eighth one, A intersection B intersection C, A intersection B intersection C. RB kansla associative law satisfied. Okay. Next ninth number, De Morgan's law, A union B whole dash, A dash intersection B dash, and 10th number, A intersection B whole dash is equal to A dash union B dash. This is De Morgan's law. Okay. Next 11. What is 11? 11 means distributive law. A union B intersection C is equal to A union B intersection A union C. And 12th number, A intersection B union C is equal to A intersection B union A intersection C. These are the algebra of events. Okay, B does not occur. Okay, these are called algebra of events. This is a question. If A, B, C are three events, then find the expression for the given events given below. Okay. So question number 1, only A occurs. Only A occurs means ए ही अकर करिवो बी एंड सी डज नॉट अकर ओनली ए अकर्स हम यूज करें वेन डायग्राम देख यूज कर वेन डायग्राम दिस इज वेन डायग्राम एस नाला को दिस वन सेट ए नल दिस वन सेट बी दिस वन सेट सी तो ए बी सी ओनली ए अकर मीन्स ओनली ए अकर यही पोर्शन खाली ओनली ए अकर्स तो ओनली ए अकर मीन्स बी एंड सी डज नॉट अकर तो यू कैन राइट सिंबलिकली ए अकर मीन्स ए रहिला बी सी अकर नुहे तो ए इंटरसेक्शन बी डैश इंटरसेक्शन सी डैश और वी कैन राइट आल्सो ए माइनस बी यूनियन सी होल डैश ए माइनस बी यूनियन बी यूनियन सी ए माइनस बी यूनियन सी इज सेम एज ए इंटरसेक्शन बी यूनियन सी होल डैश ये तीन जगह समान ओनली ए अकर मीन्स बी डज नॉट अकर सी डज नॉट अकर ओके दिस इज द थ्योरी नेक्स्ट बोथ ए एंड बी अकर बट सी डज नॉट अकर तो जोड़ा अकर नुहे तापर डैश पड़ जीव तो यू कैन राइट दिस इज ए अकर एंड मीन्स इंटरसेक्शन बी अकर बट सी डज नॉट अकर मीन्स एंड सी डज नॉट अकर ए इंटरसेक्शन बी इंटरसेक्शन सी डैश मीन्स कौड़ा आस कहल वेन डायग्राम करवा तो दिस इज ए सेट दिस इज बी सेट दिस इज सी सेट ए बी सी तो यही पोर्शन ये छोटिया पोर्शन यही पोर्शन दिस इज ए इंटरसेक्शन बी बट नॉट सी मीन्स कॉमन डा माइनस कर दो कॉमन डा ए इंटरसेक्शन बी माइनस ए इंटरसेक्शन बी इंटरसेक्शन सी तो यू कैन राइट दिस ए इंटरसेक्शन बी माइनस ए इंटरसेक्शन बी इंटरसेक्शन सी कॉमन डा माइनस कर दिया नेक्स्ट एटलिस्ट वन ऑफ द इवेंट्स अकर एटलिस्ट वन जेकोसी गोटे एटलिस्ट वन ऑफ द इवेंट्स अकर मीन्स दिस इज ए यूनियन बी यूनियन सी ए यूनियन बी यूनियन सी मीन्स टोटाल सब नहीं पार ए बी सी मीन्स सब जगह ऑल ए यूनियन बी यूनियन सी ऑल द थ्री इवेंट्स अकर ऑल द थ्री इवेंट्स मीन्स कॉमन तीन जगह कॉमन टा दिस इज इक्वल टू ए इंटरसेक्शन बी इंटरसेक्शन सी मीन्स जोटा कॉमन टा कॉमन ए सेट दिस इज बी सेट दिस इज सी सेट तो यही पोर्शन टा यही पोर्शन है तुम ए बी सी तो यही जो पोर्शन है कॉमन पोर्शन ऑल थ्री इवेंट्स अकर कॉमन पोर्शन नेक्स्ट एटलिस्ट टू इवेंट्स अकर एटलिस्ट टू इवेंट्स अकर मीन्स थर्ड वन नॉट अकर मीन्स ए बी अकर सी डजन अकर बी सी अकर ए डजन अकर ए सी अकर सी डजन अकर तो कौन करिया दिस इज इक्वल टू ए बी अकर एटलिस्ट टू इवेंट्स अकर ए इंटरसेक्शन बी इंटरसेक्शन सी डैश यूनियन ए इंटरसेक्शन सी इंटरसेक्शन बी डैश यूनियन बी इंटरसेक्शन सी इंटरसेक्शन ए डैश ये एटलिस्ट टू इवेंट्स अकर अति कम दुईटा इवेंट अकर करू नन ऑफ द इवेंट्स अकर्स कोड़ा भी अकर करूनी नन कोड़ा भी नुहे ए डैश इंटरसेक्शन बी डैश इंटरसेक्शन सी डैश यू कैन राइट दिस ए यूनियन बी यूनियन सी रो होल डैश दिस इज द कौन नंबर नोटेशन ओके दिस इज द नोटेशन नेक्स्ट वन प्रोबेबिलिटी ऑफ अकरेंस ऑफ एन इवेंट प्रोबेबिलिटी ऑफ एन अकरेंस ऑफ एन इवेंट ओके द चांसेस दैट a particular event when we perform an experiment is in technical language is called probability of occurrence of an event probability of occurrence of an event again कौन कहला the chances that a particular event, the chances that a particular event when chance that a particular event will occur when we perform an experiment is, in a technical language, called probability of occurrence of an event. Okay, next one, mathematical or classical definition of probability. Okay, let S be the sample space. Let capital S be the sample space and let E be the events. Okay, let E be an event of the sample space S. Then probability of the occurrence of the event E, then the probability of occurrence of an event E is denoted by P of E, and is defined as P of E is equal to mod of E divided by mod of S. Mod of E means number of element in set E divided by number of element in sample space S, that is number of elements in E, number of elements in E divided by number of elements in S. Number of elements in E divided by number of elements in S also is equal to number of elements favorable to number of elements or number of cases favorable to event E, number of cases favorable to the event E divided by whole divided by total number of possible outcomes, total number of cases, total number of cases means total number of possible outcomes, that is total number of possible outcomes means mod of s. Okay, this is the classical or mathematical definition of the probability. Okay, next one, axiomatic approach to probability. Axiomatic approach to probability means random events are associated with the sets. Random events are associated with the sets and probability कौन ना measure of an event, measure of these sets, okay, probability कौन गोटे measure of these sets. Okay, देखो ताहले कौन आसला axiomatic approach to probability, axiomatic approach to probability random events are associated or represented by the sets, represented by the sets and probability is a measure, and probability is a measure, defined on these sets, okay, means random events are represented by the sets, all random events are represented by the sets, probability is a measure means value de hela defined on these sets, sei set upare define kara hochi. Next, definition, axiomatic approach to probability, the definition. Okay, let S be the sample space, let S be the sample space associated with a random experiment, okay, associated with a random experiment. To each event A, capital A is a subset of the sample spaces, subset of the sample space S, subset of the sample space S. We associate a real number S, we associate a real number P of A, associate a real number P of A, then P is called probability set of function, whose domain whose domain is the set of all power set of S. Domain is the set of all power set of S. Okay, domain is the power set. Domain is the power set of S, and range is 0 to 1. That is P such that P of S to 0, 1. This is a domain. Probability is a purely function. So the domain is a probability of means power set of S, and range means probability lies between 0 and 1, including 0 and including 1. Okay, 0 and 1. Okay, and P of A is the probability of event, probability of an event, then probability of an event A, then following axioms are satisfied. Following axioms are satisfied. Okay, first axiom, axiom 1, axioms of non-negativity. For each A, the subset of the sample space S, subset of S, so P of A means probability of A is always greater than or equal to 0, means never negative. Okay, so P of A greater than or equal to 0. P of A greater than or equal to 0. P of A greater than or equal to 0 for all A subset of S. कौन कहुची यदि ए जब आम इवेंट नवा तो तार प्रोबेबिलिटीटा कौन आसो ऑलवेज ग्रेटर देन इज इक्वल टू 0, दैट इज नेवर नेगेटिव, नॉन नेगेटिव वैल्यू, तो प्रोबेबिलिटी ऑलवेज ग्रेटर देन इज इक्वल टू 0. ओके, नेक्स्ट प्रॉपर्टी एक्सियम्स ऑफ सर्टेनिटी. सेकंड प्रॉपर्टी एक्सियम्स ऑफ सर्टेनिटी. Second property, axioms of certainty. Okay, the probability of S is unity. The probability of S is unity. That is P of S is equal to 1. P of S is equal to 1. Next, axioms of additivity. Third one, axioms of additivity. Axioms of additivity. Okay, if a1, a2 up to n and so on is an infinite arrow, and so on is a finite or infinite sequence of disjoint events. Sequence of mutually exclusive and exhaustive events. Mutually exclusive and exhaustive means common नथिबो आउ यूनियन कला को एस आस्तु. Exhaustive events, that is AI intersection Aj is equal to of a sample space S, of a sample space S, that is AI intersection Aj is equal to phi and A1 union A2 union up to union An dot is equal to S. Then P of A1 plus P of A2 plus dot P of An plus dot is equal to 1 is equal to P of S is equal to 1, or summation I is equal to 1 to infinity P of AI is equal to P of S is equal to 1, means sum of the probability is always is equal to 1. Okay. Next, theorems on probability. Theorem 1. Theorem 1. The probability of an impossible event is 0. The probability of an impossible event is 0. That is P of phi is equal to 0. P of phi is equal to 0. Proof: since phi is a subset of sample space S, because phi is a subset of every set, therefore phi is a subset of S. Okay, so phi is subset of S. Therefore P of phi means probability of phi is equal to mod of phi by mod of S. So mod of phi means 0 because phi is no element. Okay, divided by mod of S is equal to 0. Therefore P of phi is equal to 0. Next, theorem 2. The probability of a certain event is 1. The probability of a certain event is 1. Okay, the probability of a certain event is 1. That is, let S be a sample space, therefore S is subset of S, implies S is an event called certain or sure event. Therefore P of S is equal to mod of S by mod of S is equal to 1. The probability of a sure event or certain event is 1. Okay. Next theorem 3. Okay, if A and B are two events, if A and B are two events and A is a subset of B in a sample space S, and A is a subset of B, then P of A is less than or is equal to P of B. P of A less than is equal to P of B. Proof: given A is subset of B. So this implies mod of A less than is equal to mod of B, because A is subset of B means all the elements of set A are in set B. तो A सब जगह एलिमेंट कोड अच्छी सेट B रे अच्छी. Therefore obviously number of element in set A is less than is equal to number of element in set B. Okay, so dividing both side by mod of S. This implies mod of A divided by mod of S less than is equal to mod of B by mod of S, since mod of S greater than 0. So this implies this is P of A less than is equal to P of B. P of A less than is equal to P of B. Okay. Next, theorem 4. The probability of a function, the probability of a event A is always lies between 0 and 1. Okay, always lies between 0 and 1. The probability of a function P of A always lies between 0 and 1, that is 0 less than is equal to P of A less than is equal to 1. देखो, okay. अच्छा, since we have A is an event, therefore A subset of S. Phi is a subset of every set. Therefore phi is subset of A. Hence phi subset of A subset of S. So implies mod of phi less than is equal to mod of A less than is equal to mod of S. Okay, dividing both sides by mod S, dividing both sides by mod of S. So it becomes mod of phi by mod of S less than is equal to mod A by mod S less than is equal to mod S by mod S. Okay, mod phi is 0, so 0 by mod S less than this is P of A less than equal to 1. So 0 by something equal to 0, so 0 less than equal to P of A less than is equal to 1. So any probability always lies between 0 and 1, always lies between 0 and 1. Okay. Next, theorem: if A and B are mutually exclusive, means common किछ नहीं, exclusive and exhaustive events, then P of A union B is equal to PA plus PB. Okay, common नहीं किसी, mutually exclusive कर दिया, not exhaustive, sorry, only exclusive events. If A and B are mutually exclusive events, common किछ नहीं, mutually exclusive, not exhaustive, mutually exclusive events, then P of A union B is equal to PA plus PB. So this is S, this one A set and this one B set. So A union B means whole. A union B mode means mod A plus mod B, because there is no common element. A union B mode is equal to mod A plus mod b. तो implies a union b रो mod divided by mod s is equal to mod a by mod s plus mod b by mod s. So this is p of a union b is equal to pa plus pb. Condition a and b are disjoint. A intersection b is equal to what? Phi. A inter b is equal to phi होते हैं पड़े वाला. A intersection b is equal to what? Phi. Means the common किसी नहीं. तो ले a union b रो mod टा कौन p of a union b टा कौन आसिबो pa plus pb. Okay. The probability of a complementary event A, complementary event A is denoted by A dash or A ऊपर C. तो this is sample space S. तो this one A set. तो बाहर टा कौन हबो कहलो बाहर टा हबो A complement. Therefore A intersection A complement is equal to phi and A union A complement is equal to S. So they are mutually exclusive and exhaustive. Implies P of A union A complement is equal to P of S. Okay. So this implies P of A plus P of A complement by theorem 5 is equal to 1. So implies P of A complement is equal to 1 minus P of A. P of A complement is equal to 1 minus P of A. 1 minus P of A. Okay. This is complement. Probability of complement of a set means 1 minus probability of A. If A and B are two events, then P of A minus B is equal to P of A intersection B dash is equal to P of A minus P of A intersection B. Okay. देखो ताहले proof देखो. Proof. We have this is a Venn diagram. This is sample space S. This one set A. This one set B. So this is A minus B. This set is A minus B. So A minus B means the elements belongs to set A but not belongs to set B. So we have A set. A is equal to A minus B union A intersection B. A minus B union A intersection B. Okay. And A minus B intersection A intersection B is equal to phi. Means एटा भितर किसी कॉमन नहीं, नो कॉमन. Therefore P of A is equal to P of A minus B union A intersection B. तो is equal to P of A minus B plus P of A intersection B because they have no common element. So P of A union B equal to PA plus PB. Therefore P of A minus B is equal to PA minus P of A intersection B. P of A minus B is equal to P of A minus P of A intersection B. A intersection B. Okay. Also A intersection B dash means what? A intersection B dash means B को छाड़ीगिरी तो only A. Okay. So if find P of A intersection B dash means we can find P of A minus B. Similarly P of B minus A. P of B minus A is equal to what? P of B intersection A dash is equal to P of B minus P of A intersection B. Remember this formula. Okay. बुझीपारछ P of A minus B is equal to P of A intersection B dash is equal to P of A minus P of A intersection B. Next one, addition theorem. Addition theorem for only two events A and B. Okay. If A and B are any two events in a sample space S, then P of A union B is equal to PA plus PB minus P of A intersection B. PA plus PB minus P of A intersection B. देखो प्रूफ देखो ठीक है. This is the Venn diagram. So this is S. So this one A set and this one B set. Okay. So A union B means what? Whole. So A union B means only A union B. So this is A minus B union B. From the Venn diagram, A union B means A union B is equal to A minus B union B. A minus B union B. Here A minus B intersection B is equal to 5. So this implies P of A minus B. This implies P of A union B is equal to P of A minus B union B. So since if A and B are disjoint, then P of A union B कहले PA plus PB. तो जेहेतु A minus B and B are disjoint, इधर disjoint common नहीं किसी. Therefore P of A minus B union B कहले P of A minus B plus P of B. Okay, but P of A minus B equal what? PA minus P of A intersection B. P of A minus B is equal to PA minus P of A intersection B plus P of B. Okay, since P of A minus B is equal to P of A minus P of A intersection B. Therefore, P of A union B is equal to PA plus PB minus P of A intersection B. Okay, hence proved. Next theorem, for any three events A, B and C of a sample space S, of a sample space S, कौन अच्छी ना A union B, probability of A union B union C. Okay, probability of A union B union C is equal to probability of A union B union C is equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. एटा हम प्रूव करी देखते हैं. प्रूफ. ओके. अच्छा. Probability of A union B union C is equal to probability of A union D, where D is equal to what? B union C. D is equal to what? B union C. So E is equal to, by last theorem, P of A union D means P of A plus P of D minus P of A intersection D. So is equal to P of A plus P of D. What is D? D is B union C minus P of A intersection D means B union C. So is equal to P of A plus again use B union C formula, P of B plus P of C minus P of B intersection C minus curly bracket P of A intersection, this is P of curly bracket, use distributive rule, distributive theorem, A intersection B union C means A intersection B union A intersection C. Okay, so is equal to P of A plus P of B plus P of C minus P of B intersection C minus again use P of A union B formula, P of A union B is equal to PA plus PB minus P of A intersection B. So use the formula curly bracket P of A intersection B plus P of A intersection C minus P of bracket A intersection B intersection A intersection C, intersection A intersection C. So is equal to P of A plus P of B plus P of C minus P of B intersection C minus P of A intersection B minus plus minus P of A intersection C minus minus plus. अच्छा, A intersection B intersection A intersection C means A intersection B intersection C. So this is minus minus plus P of A intersection B intersection C. Hence proved. Okay, A intersection B intersection A B रो common, तापर A C रो common, both रो common again common, that is called A intersection B intersection C. Okay, note मन रखो, note for any two events A and B, we have P of A intersection B is less than or equal to P of A union B is less than or equal to PA plus PB. A intersection B is always subset of A and B. A intersection B is subset of both A and B. A and B also subset of A union B. So obviously A and B subset of A union B. Therefore P of A and B less than or equal to P of A union B. Next, P of A union B means what? PA plus PB minus P of A union B. Suppose A and B are disjoint, then P of A union B is equal to PA plus PB. Therefore P of A union B is less than or equal to PA plus PB. Okay. Next, second one. It like that. This is the first one. Second one, P of A union B, P of A union B is greater than or equal to PA plus PB minus 1. Greater than or equal to PA plus PB minus 1. Sorry, this is P of A intersection B. P of A intersection B greater than or equal to PA plus PB minus 1. Okay, prove the criteria. Prove we have A union B is always subset of sample space S. A union B कार subset, S रा subset. So this implies P of A union B is less than or equal to P of S. So P of A union B means PA plus PB minus P of A intersection B less than or equal to 1. So implies PA plus PB minus 1 less than or equal to P of A intersection B. तो एटा आठ छोट तो ये आठ बड़ So this implies P of A internal B greater than is equal to PA plus PB minus 1. Okay. So these are the algebra of probabilities. Next class we shall discuss some problems of probability from exercise and some extra theory.